Good day, everyone. Welcome to That Friendly Writer Statistics and Data Analysis tutorial videos for TVL students. This is my YouTube channel where you can watch lots of statistics and data analysis videos. Today, we'll learn about hypothesis testing. This is an introduction video that explains rejecting a null hypothesis using both statistical and non-statistical examples. Alright, let's get started. Before we begin, what is a hypothesis test? It is a formal procedure to evaluate a specific claim using evidences that have been gathered. In statistics, it is used to evaluate claims about the population using the sample data that we have. Take note that a hypothesis test does not show that a claim is true or false. We'll explain this more later. We have new terms related to hypothesis test. The first one is the alternative hypothesis, which is the claim of the researcher. It is a statement that something has an effect, has a difference, or has a change. For example, we're claiming that a certain politician is exercising corruption of money. This is the claim that we try to verify. The symbol for the alternative hypothesis is HA. The null hypothesis is the opposite of the alternative. This is the statement of equality, no effect or no change. This is considered as the status quo, meaning this is the inherent, natural, or acceptable quality. The null hypothesis is the wall that we need to overcome or reject in order to consider the alternative hypothesis. If we can't reject the null hypothesis, then that means we cannot consider the alternative at all. In the example of the politician, before we can say that the politician is corrupt, we must be able to reject the null hypothesis that he is not corrupt at all. It's up to the accuser to provide very strong evidences in order to reject this null hypothesis. If the accuser can't do that, then we cannot say that the politician is corrupt. This is the purpose of the null hypothesis. Its symbol is HO. Now, hypothesis test is not a true or false game. Our conclusion may be right, hopefully, or there would be unfortunate times our conclusion is wrong. In this case, there is always a possibility of error. There are two kinds of errors, type 1 and type 2. Type 1 error is when we judge there is an effect, but in reality, there really is no effect at all. This is called a false positive. Type 2 error is when we fail to judge there is an effect, but in reality, there really is an effect. We fail to notice it. Thus, this is called a false negative. In hypothesis test, we must be very careful with our evidences so as not to get either type of error, because making errors like this may be costly at times. Let's have some real-life examples. You notice that John is very soft for a guy, so you start to doubt whether he is straight. You claim that John is a closeted member of the LGBTQ. So this is our alternative hypothesis. This is our claim. But then again, we cannot just broadcast this especially to everyone. We must test this hypothesis. To do this, we form our null hypothesis. Our null hypothesis is John is not a closeted LGBTQ. This is our initial mindset, and it is up to us to reject this null hypothesis using the evidences do we have. But what evidences do we have? That John likes volleyball over basketball? That he prefers to be with girls than boys? That he takes up home economics and not welding? That he is an only boy in the family? So, based on this, do we have enough evidences? The answer is not enough. Just because someone plays volleyball than basketball does not mean a man is LGBTQ. Just because a person takes up home economics and not welding does not mean he's LGBTQ either. The other evidences are also very weak. Hence, we cannot reject the null hypothesis. Therefore, the idea that Jonathan is not an LGBTQ remains unchallenged by the weak evidences. If we want to truly verify that Jonathan is LGBTQ, we must look for much stronger evidences against this null hypothesis. Otherwise, we cannot reject this at all. Now, we're not saying that we're 100% correct. Our conclusion may either be right or wrong. If we're correct, then that's good for us. But if not, then there are two possible errors. Type 1 is when we accuse him of being gay, but in truth, he is not. Type 2 is when we fail to recognize that he is gay, but in truth, he is one. Here's another example. Janine is depressed because she believes that her partner Mike is cheating on her. This is her alternative hypothesis. Of course, Janine should be logical. She can't immediately say that her partner is cheating. So her null hypothesis HO is her partner Mike is not cheating on her. At least give him the benefit of the doubt that he is loyal. Now, what evidences does Janine have against this null hypothesis? Number 1, a new cell phone lock. 2, long waits for Mike's replies. 3, Mike quickly gets mad when asked where he went. 4, Janine discovered a secret conversation with another woman. And number 5, ILY and 143 are short code messages for I love you. Janine also saw heart reacts in the messages. Now these are strong evidences against the null hypothesis that Mike is not cheating. These evidences show that we must reject the null hypothesis. Again, we're not 100% sure that Mike is indeed cheating, but the evidences are so strong against the null hypothesis that the only logical thing to do is to reject it. What do we consider? The alternative hypothesis that Mike is cheating. Now, the two possible errors from this situation are: type 1, Janine accuses Mike of cheating, but who knows in reality, he is actually not. Or type 2, Janine let go of or ignored the signs of cheating, but the truth is, Mike is a real cheater. We now have an idea on rejecting the null hypothesis. Now, how about statistical hypothesis testing? In this example, we believe that the population mean mu is less than 100. This is our alternative hypothesis. What is our null hypothesis? That the mean mu equals 100. Take note that the null hypothesis is always a condition of equality or no change. Therefore, the null hypothesis always uses an equal sign. What evidence do we have to challenge this null hypothesis? Well, the statistic 1.50 did not exceed the critical value 3.221. It falls short. Second, the probability of getting a statistic as extreme as this one, assuming the null hypothesis is true, is 0.50 or 50%. A probability of 50% is nothing special. It is still a common p-value. Hence, what do we do with the null? We fail to reject it at all. This means that we still consider the mean mu to be 100, and we do not have sufficient evidence to reject this idea at all. How about a second example? We believe that a population average is above 50. This is our alternative hypothesis. But we don't immediately accept this, so we need the null hypothesis mu equals 50. Remember, the null hypothesis always uses an equal sign. For the evidences, the statistic of 4.26 is greater than the critical value 3.221. Second, the probability that this extreme statistic occurs is only 2%, which is a rare chance to happen. Therefore, the logical thing to do is to reject the null based on the evidences. So, we have evidences to believe that the population average is truly above 50. There we go, hypothesis testing. Going back to the example of the corrupt politician. Inasmuch as we claim that the politician is corrupt, this is our alternative hypothesis. But courts always assume that every person is innocent or did not commit any crime. This is the null hypothesis. And it is the prosecutor's job to present the evidences that will fully reject this null hypothesis. And the judge eventually makes the best logical decision based on the evidences, whether guilty or not guilty. But remember, this is not absolute. The process may still entail either type 1 or type 2 error. If the judge charges the politician guilty, but is truly not guilty, this is type 1 error. If he announced not guilty, but the politician is really guilty, then this is type 2 error. And there we go, hypothesis testing. For your practice, try to do this task. Pause this video and try this out first. I will now show the answers. Alright, in 3, 2, and 1. These are the answers. How did you do? Were you able to fill out the statistical tables correctly? Alright, this concludes our video for today. Hope you learned something new, and have a friendly day!